Okay. Hello, everyone. Welcome to the second day of the DSC MENA Region 2024 Hybrid Conference. I hope you had a beautiful day yesterday. This is Minna, and I'll be here as a tech support during the tutorial. And I want to introduce you to our first tutor for the day, Karim Tawfik. Karim is the CTO at Simple, and he will hold a tool showcase under the title Build CDC Pipeline Use Kafka Ecosystem. I hope you all enjoy today. Thank you.
Thank you,
So
Manna.
we can start here.
Yeah, sure. Hi everyone, this is Karim Tawfik. Good morning and thanks for joining the session. I know it's Friday morning and I think most of you is most probably from Egypt. So yeah, thanks for waking up early in your vacation and attending a technical session. So I think it's really nice of you, and I hope you get benefit and see whatever you were expecting. During this session, let me introduce myself quickly before we gonna start. This is Karim Tawfik. I'm a co-founder and CTO of startup here in Egypt called Simple. It's mainly working in the buy now pay later in the fintech industry. We've been in the market for maybe the past almost 3 years. In a few months, we'll be closing 3 years. Before this, I was working as head of engineering at a startup called Capter, and before this, I've been working in US-based startups and companies more. A company called Agolo. It's mainly in the NLP field. And before this, another company called Arrow Electronics. It's mainly in the data field, electronics and data field. And the last one is actually the first one is Visa. So I have almost a collective years of experience, around 14 years of experience in the tech industry between software engineering, data architecture, and building startups and so on and so forth. So yeah, let me just share the screen, prepare the screen sharing. I mean, most probably since it's a more of a hands-on session, it will be a very, very small presentation that will be just discussing quickly on the definitions, the aspect. Let me also consider the comments. Okay. Okay, so I think maybe the questions we might open it up by the end of the session, or if I find something maybe relevant to the session, we can answer it during the session. But questions like, I want to ask a question depending on the experience in the market. Okay, please go ahead, shoot your question, and I'll go through it maybe in the middle or the end of the session. Okay, so let me share the screen. Can you see my screen now?
Yes, I can see it.
Yeah. Respond to the chat. Yeah, okay. First of all, I'd like you guys in the chat, if you can mention that if you're working in the technical field, have you ever touched the data domain or the data engineering domain or not? Just to set the ground of the audience and know more about your experience. So I appreciate if you can just quickly write or just send a message saying that you have a technical background, you're working as software engineer or not, or data engineer or not, you're just the job maybe. Okay. Okay, so until the audience write their responses. Okay, let's before jumping into the technicalities, let's discuss what is a real case scenario problem that's happening on ground, and I witnessed a lot in startups, early stage startups, medium-sized companies, corporates, and medium-sized corporates. Let's assume that we're trying to build an e-commerce application, for example. This e-commerce application will contain or must contain definitely database, backend, and maybe something like front end, a web application or mobile application. Okay. Actually, let's so that you are in the session. So like maybe wait a little bit. So yeah. Okay, let's assume we have maybe something like a database, mobile application, web application, admin portal, and maybe something like an external services. We're dealing with something like stock management service, and maybe something like ERP. Okay, so in the real case scenarios whereby the business want to jump into the market and penetrate the market, they pressure the tech team very strongly to get product in the market. Okay, so once we get the ecosystem established and built in the market, and they are operating, exactly the day after, the business, all the stakeholders try to push very hard to get reports and analytics. So tech team is in the middle of troubleshooting, making the system stable, uh, monitoring the system all over around the systems, getting feedback from customers, getting feedback from internal teams like operations, call center, stock management team, so on and so forth, and trying to fix problems as they go. So they don't have time yet to build the analytics platform or the analytics infrastructure so that they can get reports as expected. So the very big mistake that happened in most of the companies, no matter what, it is small, medium, or enterprise, is that they grant access to the analytics engineer to the database. So the database here, let's say it's MySQL or Postgres, Oracle, SQL Server, whatever, name it, or something like a non-relational database like Mongo or so. So this database, we call it the OLTP, Online Transaction Processing Database. OLTPs by design, they are designed for to be normalized, to be used for CRUD operation more, reading a record, reading multiple records, few records, saving a record or saving multiple records. So it's not intended for, analytics. It's mainly designed based on something called row-based structure. And what basically does row-based structure mean is that the storage layer of these databases, any relational databases, it's storing the data in a row structured format in the disk. So what does this mean? This means that whenever a reading request happened, the database by design, it has to go to the disk and load a page, a file page from the disk. And this file page contains the entire record of this row. So let's say I have an orders table and I want to get something like the total orders has been placed in the past 7 days, aggregated by the day. So day over day, total sales, amount, and count in the past 7 days. When I go to the OLTP database and run an aggregated query or an aggregation query, something like select count asterisk and sum the amount from orders table, group by and date as well, and group by this date. So in this query, the database engine has to go and read all the records that are matching this condition, no matter what. I'm just picking a specific or single column, which means I have lots and lots of disk reads activities happening, which slow the reporting and slow the database entirely. So OLTP by design, it's not for analytics and reporting. It's more for CRUD operation, reading small amounts of records, persisting small amount of records, or reading a single record and persisting a single record. The normal CRUD operations we use to do. So after launching the system, as I mentioned, the stakeholders like the CEO, the chief financial officer, the chief customer support officer, so on and so forth, they start to chase the analytics team. I want to get the reporting. I want to see the KPIs of my team. I want to see how we're progressing. I want to see how we can expand in this area or stop in this area, so on and so forth. So analytics start to get aggravated from the business or the stakeholders as the business grows. One of the biggest mistakes, as I mentioned, is the engineering team or the tech team grant access for the analytics engineer on the database. So the database, as we mentioned, is designed for online transaction processing. It's following the normalization patterns. It's more for reading and writing small amounts of records. So things works fine for maybe 6 months, 9 months. After that, we started to see a very, very slow performance from the database. So when we get back to the monitoring and alerting, so on and so forth, we found that the analytics team have built a huge amount of reports, some of them running on a monthly basis, others running on a weekly basis, others on a daily basis, others in a real time. So we find eventually maybe hundreds of queries running on our database, which resulted in very slow response from the database, which is not only slowing the reporting, but also slowing all the users, the end users interacting with the system. So having the online or OLTP or the live database being used to serve the front end or the live application and serving as well the analytics team, it's a no option. Make sure that in your company you're avoiding this pattern. It's horrific and it's really hard to do. Not only that, but also the analytics team, they are not just querying the database. they're also looking for creating materialized views, aggregated tables, custom metrics. They might use your database to create something like a data catalog or a data mart. So the engineering team who are maintaining the database that should be serving the online applications only purposes, whether it's an internal or external. External here, I mean the customers, the end customers, and internal, maybe the operations, the call center, the users in the warehouse, so on and so forth. So the database is intending only to serve these kind of users, but it's not intended to serve analytics purposes. So getting back to the point, the analytics engineer, it's not only about just querying the data or understanding the schema and architecture to generate reports. They need to follow some data modeling pattern like star schema, snowflake schema, maybe wide flat table schema. So it's not right to have these all kind of changes or updates happening on the same database. But anyway, it is what it is. Let's assume, given our scenario, that we started already with giving the analytics engineering team an access to our live database. So what should we do next? At least the very first step has to be done is replicating the same scenario, getting our same database, but split it to another instance, which is the read replica. We can create a read replica or a master-slave architecture whereby this database is serving the customers and clients, customers and internal users, and this serving analytics purposes. Okay, so by this design or by this architecture, we have splitted the load or decreased the overwhelming load on the database, and it's just solely serving its main purpose, which is internal user systems and customer services and customers APIs and apps, I mean. So, okay. So the read replica will be serving, as mentioned, the analytics purpose. Again, from its name, it's only read replica. We can't update, we can't create tables, we can't do any kind of stuff on this read replica. And again, the analytics engineer, it's not working as a read-only user. The analytics or data engineering or data science, when it comes to the data modeling, there are very extensive techniques and advanced techniques to do data modeling for analytics only, not for online applications. So, as mentioned, Snowflake, star schema, Kimball, design, Bill Inman, a big flat table. So there are lots of design aspects and techniques when it comes to data warehouse modeling, or analytics modeling. So by having this option, system gonna work maybe for 1 year. It depends on the scalability of the system and the growth as well. But let's say it worked fine for 1 year. After 1 year, again, the analytics reports or the analytical reports started to get delayed, started to be not as accurate as before. The business stakeholders start to be complaining about the latency, about the inaccuracy of the data, about the very, very long time, even if the report got generated. When I just ask or request a report on the reporting tool that we're using, the report takes forever to get generated. So again, we're not, by this option, we're not solving the problem. We're just getting it a little pain relief. It's not the ultimate option to solve this problem. Why? Again, it's a read-only database, so the analytics engineer cannot build custom views and aggregated models. The database, it's designed for reads and writes for CRUD application, but it's not for analytical purposes. As since I mentioned the row-based structure, the data warehousing models are built on top of something called columnar-based structure, whereby the storage here, we're mentioning that the data is stored in a kind of rows. So let's say ID, name, mobile, email, so on and so forth. So each block of this entries contains the entire record. While on the other hand, when it comes to the data warehouses, it's stored on a columnar based, whereby this is the name, email, mobile, ID, so on and so forth. So this means that when it comes to the disk read that's happening by the data warehouse, when I go and ask for how many users we acquired yesterday, how many users have been onboarded on our system yesterday. So we can just easily, the data warehouse can go and get all the users with a kind of a very, very minimal disk reads to get them in maybe 1 or 2 or 3 page reads. However, on the other side, and only get the column that's intended to be read. However, here, the pages has been read contains column that are not intended to be read. I don't want the disk to read the name, the mobile, the email. I don't want all this stuff. Okay. So that's why one of the biggest purposes, the analytical warehouses are super fast, because they are depending not only that, but this is one of the biggest reasons. It's mainly structured in a columnar structure basis. And even for the data lakes or lake houses, so on and so forth, they are depending on files called columnar-based files, something like Howdy, like Parquet. These kind of file formats are structured internally to be a columnar-based. So it's not only related to the SQL-based data warehouses like SSIS or any kind of warehouse, but also it's now open for the data lake structures, Delta Lake, whatever, lake houses. All these kind of platforms are depending right now or mainly on open formats, open file formats like Howdy and Parquet. So the long story short, as you mentioned, I hope I was able to convey the message or the problem of the reporting pain. I think it's happening in almost all the companies, and I've witnessed it. I've witnessed this in my companies and companies I'm working for as a consultant. They were stuck with, they have a very good technology, they have very good product, but they were not able to fulfill the analytics requirements. And being that said, you're not able to fulfill your analytics requirement, you're not able to see or read the data. And one of the funniest thing I've heard maybe in the past 5 or 6 years is that having this kind of very bad situation that you're not able even to generate fast reports, and some companies asking for going to AI side and building data science team and building very strong machine learning models to capitalize on the data. Doesn't make sense. Hearing this, it's totally nonsense. You need first to build the proper data architecture and streamlining the data making sure that the system is operating with no firefighting every now and then. You have a strong data model, and only then you can think of building advanced analytics, maybe prescriptive analytics, maybe something basic machine learning models, getting some forecasts from your data. But it's totally funny that you get the feedback from maybe a CEO or a CTO or something like this. We need to build a AI team or hire data scientists, and we don't have the data sources aggregated in somewhere. And by the way, the scenario that I've been mentioning here, it's only covering the data, the database. But in the real life scenarios, any application, name it, any application now have 3 to 7 or to 10 data sources. The database, okay? External systems like ERP, CRM, user tracking systems, something like Engage, Pixel, Google Analytics, whatever. Social media data. Like whenever you have a marketing team, so you have maybe uh, social media listening and getting the feedback from the social media, so on and so forth. WhatsApp integration. Yeah, these are maybe 5 or 6 options. So actually, one of the biggest problems happening here is manual generated files, manually. Manually generated files here, it's a very open-ended word, whereby you have a system and you have reports and you have everything in place. But for some reasons, a specific team members or a few team members in different departments, they adore working on Excel files. They take the data from the system and work on Excel files out of the system and generate reports on Excel files and generate content on Excel files, and which is not uploadable to the system. So they start to create a kind of a branch out of the system, and this branch is one-way branch. They can go back. So by time you're gonna find that some team members, they build their own workflow out of a specific point from the system. So they take a line from the system and build workflow around it, maybe for sales, maybe for finance team, maybe for operations, whatsoever. And by design, as a data architect, as a data architect, or even a solution architect, at some point in time, you will need to get benefit of this ecosystem. You can't just drop it. So you have to jump in, understand this workflow, understand what this kind of files being generated, how they are being generated, what are the business logic behind these files, and try to integrate it with your system until you totally close it or delete this flow and implement it from your system. But ad hoc files are the nightmare for data engineers. So, but they are nightmares, but they must work with. So you have lots of data sources. How the analytics engineer will work with this data? So for the database, assuming that it's an SQL and the analytics engineer can work with it, it's fine. But what about other sources? I'm getting data from an external API. I'm getting data from an external database. I'm getting data from non-relational database. What shall I do? Or how shall I integrate with this? So I think it's totally clear now that we need to think of a solution that's other than data replication, other than getting access to the analytics team on the live database, to streamline all these data sources, aggregated it and streamline it to a destination. And this destination would be the starting point for analytics team, for data science team, for whatsoever team, to generate their reports or business flow. Here we come to the ETL concept, or the ETL pattern or architecture. ETL pattern or architecture, it's a very, very old way or technique, maybe starting from the data warehouses in 70s, something like this. But it was not that materialized as we speak right now. There was always the need to migrate data from system to another in a real time, or in a batch time, or even on a very long batches, maybe every month or every 3 months or every 1 year, or one time when I'm migrating from old system to a new system. So here it comes the concept of the extract, transform, and load. And now there is ELT, extract, load, and transform. But it's not the venue to discuss the differences. But in a nutshell, it's these techniques are evolved due to the fact of, at some point in time when we discussing, or the evolution of the data lakes happened, they found that they have lots and lots of data being stored for no reason, or there is a very, very big ball of mud of data, which we call data swamp. However, I think there is no, yeah, it's مستنقع. يعني we just call it swamp as مستنقع, and it's unreadable. I can't get a benefit out of it. I can't get any kind of added value out of this data swamp. So the other approach is, let's process the data first before we store it, so that the data, it's kind of semi-processed. So whenever someone get to this data, might be able to understand what's the rationale of it, or reduce the dimensionality of this data. However, on the other hand, when we come to the processing first, it comes at cost. I'm processing every single message passing by the system, which resulted in maybe high cost. I'm paying money for data being processed that might also end up that's not being used eventually. So maybe we can open another discussion for the ELT, ETL, and reverse ETL techniques. But let's focus this discussion on the CDC. I know I'm taking a little bit more when it comes to the concept, but it's really important to understand, as CDC systems are complex. So to understand the complexity coming from CDC, we need to understand first what is the problem and why these systems evolved. So it's not complex we're not using CDC systems, or maybe Kafka or Kafka Connect systems for just for being in love with Kafka, or for being with love in CDC tools, but they are solving a very, very big problem. So it's kind of trade-off. You need, yes, you're introducing a new system, you're introducing maybe complex system to maintain your data pipeline. However, you're saving yourself money, you're saving your company frustration and bad feedback in case of the old structure here. Yes, here, by introducing latency for the database, customers will be frustrated. Customers will be giving you a very, very bad word of mouth for their experience. The system is too slow, the system is shitty, I can't make an order, I can't search for my product, so on and so forth. So you will get a very bad feedback from your customers, not only from customers, but also spreading a very bad word of mouth. Internally, the system will not be as dependable or reliable as it sounds. Internal teams will start to lose trust in the system if the system is buggy or the system is very, very slow. So you're decreasing or shooting the productivity of the entire team. So I know, and I can hear it since I'm a data engineer and slash CTO. I can see the pressure coming from the top management, but I understand as well the consequences. So it's really important to be this guy that doing the balance between how we can build the solution. We're not stopping the business. We're not capping the business to grow, yet foreseeing how we can scale later on. It's not, I'm not saying to build a full-fledged system from day one. It's not gonna happen, but you need to see how can I scale, how the system gonna scale. So it's really important, not just build system for now and just pushing away the pressure coming from the business or the top management to get, yeah, you want this feature, take it. Don't do this. It's really gonna bite you back. So I think I'm done with the my iPad and pen writing. Let's go for the yes. Let's share here. Okay. Let's discuss quickly what is CDC. CDC stands for Change Data Capture. A change data capture is a pattern or a technique used to migrate data from a source to a destination via a medium. A medium here could be, in our case, or in our demo day, is the Kafka architecture or Kafka ecosystem. In other systems, maybe something like cloud storage, if you're using any cloud-based CDC tool, something like data streams uh, from Google Cloud or Glue from AWS. Most probably they are depending under the hood on S3 for AWS and cloud storage for sure cloud storage, as I used this before lots of times. When it comes to data streams, they are depending on cloud storage. So they use the medium of file storage to stream the data to from the source, and the destination is listening on this data. So, okay. There are different ways of implementing the the CDC. One of them, let me just get this here. I just want to see. Anyway, not sure how much. Oh, yeah. Yes. Okay. There are lots of techniques and challenges when it comes to applying CDC. Let's discuss first about the techniques. The first technique is just replicating the data as is from the source to the destination, which is taking all the tables, the data as is without any kind of manipulation from our database or from our file system or from our external APIs or whatever, and just store it in our destination source. Okay, this called without denormalization flow or without denormalization pattern. We just take it as is and store it on the other side. The second option is taking a materialized views, assuming that we have maybe something like in MySQL, which will be our database in this demo. We're using MySQL as our database or live database and want to migrate this data from MySQL to BigQuery. Okay, so I need to get this data, not actually before getting this data, assuming that the analytics engineer is already has worked on MySQL to generate some reports following the old pattern. Okay, so it can go back to the data engineering or the engineering team. Guys, can you help me with creating a materialized view so that it accelerates the reports, so on and so forth? So the tech team helped him with this materialized views or views. So one of the techniques also is to make the migration effort much easier. Some databases support CDC on materialized views. So this another technique. Other option is migrating the data, and in the medium or in between the source and destination, I do the manipulation of the data. Do something like an aggregation or the materialized view. Basically, the concept of the materialized view, instead of doing it on the database, I can do it on the medium that I'm syncing the data on. Like Kafka, for example, there is a technology provided by Kafka called KSQL. So KSQL, basically, it's SQL on top of Kafka. So I can create from different topics or different streams some kind of materialized view, and this materialized view gonna be linked to the data warehouse. So we're using, as mentioned, Kafka and Kafka Connect ecosystem. In a nutshell or in a high level, Kafka ecosystem is mainly it's used for message as a message queuing system. But this is the very, very, very old or the very niche what they call it, the very niche usage of Kafka. Okay. However, Kafka is much bigger than this. It's some others call it database. Some others use Kafka as a database. It's used for data streaming or real-time streaming and batch processing, event-driven architecture, asynchronous, any kind of asynchronous communication. What makes Kafka really, really special is the very low latency structure or nature for Kafka and the very, very high throughput. It can process millions, maybe 5 or 6 million requests per second. And also it depends on your infrastructure and cluster size, so on and so forth. But the average benchmarks are around 3 to 5 to 6 million requests per second, and also depend on the message size itself. So Kafka ecosystem or Kafka Connect ecosystem, it's basically we're putting the component of Kafka Connect between the data source and Kafka. Okay, so which means the connect will connect to our Kafka Connect will connect to our data source, which is MySQL in our case, and listen for all the updates happening on this database. And these updates could be DDL or DML updates. DDL for insert, update, delete, or DML when it comes to updating the schema itself. Okay, and we'll see how this is happening under the hood. So Kafka Connect, listen for this kind of changes, take these changes or ingest it and push it down the stream to Kafka. Okay. On the other side, there is kind of something called the sync connector. There is the source connector. This is the source connector, and this is the sync connector. Okay. Source connector is the one getting from the source, putting to Kafka, and the sync connector is the one getting from Kafka, putting to our destination. Okay. And this is the bare minimum setup. You need to have two connectors in case you're taking from source to a destination other than Kafka. So let's assume that I just want the data get from my database to Kafka. So I need single connector. I need my data go from MySQL to BigQuery. I have to have two connectors, one from the data source to Kafka and one from Kafka to the destination, which is the source connector and the sync connector. Okay. Yeah, there is something called converter. Converter here can be a kind of lightweight a lightweight library or lightweight API attached to the connector. I can convert the message from maybe JSON to Avro to protobuf to plain text to just a string. So converters are used as a lightweight decorator on top of Kafka Connect to transform the message from a format to another. Before jumping into the next slide, any questions so far related to what we've been discussing? For Sana, yes, Sana, sorry for the late response, but yeah, you didn't miss anything. For the first grade, I think we might answer this at the end. Explain this a little bit. Okay. So, perfect. Okay. Kafka Connect has mainly 6 components. The connectors is the task, or sorry, the component that connect data from or do the processing for data streaming from source to a destination. Okay. Tasks is connector contains of multiple tasks. So I can have a connector syncing the data from MySQL to Kafka. And this can be work in a single thread or a multiple threads. Multiple threads or a single thread here, I mean the tasks. The number of tasks running under this connector can be single threaded or multiple threaded. The workers here are the server of Kafka Connect. As you know, we're working on Kafka by design is a distributed system. So it's built on the distributed system architecture. Hence, it can work on, it can be deployed in a distributed system, in distributed nature. So multiple workers can be working on a cluster, and this cluster coordinate the work between the different connectors so that we can parallelize the streaming of the data, assuming that we're streaming data from lots of sources or a source that contains a very big amount of updates happening in a specific time. So yes, I can see someone raising his hand. Yes, Yusuf, can you share your question? I think I can.
Hello, Mr. Karim.
Nice. Karim.
I want to ask you one question. He not related to what you're talking about, but it's very important to me.
Sure.
How to merge concept that I learned from college and what the market really need, especially in big data, and how it related to artificial intelligence field because I study because I'm level 3 of artificial intelligence in Kafka University. So I study already big data course, and already my doctor reached to Kafka, but I see this concept is very hard to understand because we are not studying software engineering or something like that. We just study Python or the tools or that or the concept courses that help us to understand artificial intelligence.
So
For
you didn't study software engineering, for example?
yeah, we study as a course, no, but the courses, the sub courses that gather gather it to make software engineering, like C++,
Yes, I see.
Python,
I see.
networking, كده.
Okay. What university or college you're in?
Artificial intelligence in Kafka Connect University.
Okay. Okay.
It's the first college in the Egypt specialized in artificial intelligence.
Okay. Quickly, in order not to deviate from the subject, but definitely you need to follow courses. It doesn't make sense to understand or to work with something like Kafka, any distributed system or any distributed or any solution or tool that's based on distributed system design and architecture without understanding software engineering aspects and software concepts and distributed systems concept. Distributed systems is it's a big field that's based on things coming from parallel processing, things come from storage and retrieval, things come from core software engineering. So it's a very complex or a combined science coming from multiple sources. So I can go to study a specific tool or a set of tools, depending on distributed systems without understanding distributed systems, without understanding operating systems. So my advice or my nutshell advice is to try to get online courses from maybe MIT,
Hello,
Stanford.
it's my doctor in university. Started the course with operating system already. He teach us scheduling algorithm in disk or operating system in general. So it's make give to us what we use in big data. Is
Yes,
it
but
it's just enough?
since you get the kickoff, you need to continue on your own, maybe taking courses
Yes,
from
for sure,
like
for sure.
Stanford or MIT. I think this
Coursera,
is, sorry.
like Coursera.
Maybe yeah, Coursera you will find courses from Stanford and MIT on computer science, distributed systems, operating systems. So I think I
Uh,
highly recommend. Maybe I can
Sorry
we
for
can connect.
interrupting you, but can you recommend a course for cloud or distributed system for specific? Because I
Yeah, I
research
think
a lot of.
yeah. Let's take this. Okay, after the session, you can connect with me on LinkedIn, and I can share with you the
Yeah,
this kind of.
appreciate it. Thank you so
So
much.
you're welcome. So getting back,
But
sorry for
yeah,
this. Okay. So the okay the mm, sorry. Okay. So getting back to the components. Uh, Getting back to the components. There is the connector, as mentioned, is the core task that's doing the processing. Task is a sub-child of the connector. Workers are the actual server running the connectors, which is inside the connector, the task. So workers here are the server. So I can run multiple connector server workers so that I can parallelize the processing. Converters here are the components that are used to convert message from JSON to Avro to protobuf. Transformers are another libraries used in Kafka Connect to transform the message. Something like not the format of the message, but the content itself. I need to mask a specific field. I need to encrypt a specific field. I need to add a timestamp to my message, so on and so forth. So in this case, we use transformers. And eventually the dead letter queue. What is dead letter queue in distributed systems in general or system architecture in general? Dead letter queues are a technique used to send a message in case of failure of processing a specific message. Something like, let's say, I'm listening to updates happening on a specific table in the database. And when I read this update, I am, as a processor or a connector, I'm not able to process this message or this record. What should I do? How should I handle this? And how should the one send this message know that I was not able to handle this message? There are a couple of ways. The first one is I drop the message and silently, without mentioning anything and without saying any, raising any flags or raising any errors, which means I drop the message. Okay. And this is very critical in systems related to payments, any sensitive system. This is very critical and can be done. Okay. The other option, instead of silently dropping the message, the next option is sending the message to another queue, which is called a dead letter queue. This dead letter queue will be containing the messages that the consumer was not able to process or the client was not able to process, so that I can have a place whereby when I check this place, I know what are the messages that were not able to process and why they were not being able to process. Okay. I think let's jump into the fun stuff about the implementations. Okay. We will be using Docker, okay, and Docker Compose to get things working. Anybody familiar with Kafka ecosystem, Docker and Docker Compose? I appreciate if you can interact on the chat space. Okay, let's start. Okay, Sana, thank you. Okay, in a quick nutshell, Docker and Docker Compose is Docker specifically is okay. Docker specifically is a containerization framework used to containerize application to run anywhere. This is mainly the basic concepts of containerization. It's an application running on top of your host machine. My laptop here is the host machine. I'm running on top of it Docker, and Docker is acting as a virtualization layer that can accept any application, can run on Docker without knowing for this application to know anything about my host machine. So this is the kind of state-of-the-art way of running applications without installing it locally, something like this. So you can think of it actually as it's maybe kind of not really the best scenario, but for simplicity, on your iPhone or your Samsung mobile or Android mobile, you have the Play Store and App Store. Okay. Okay, Abdullah, I'll reply to this. You have the App Store and Play Store. You don't go yourself and download the application from the developer or the company who made the application and they get the file, installed it on your mobile, and take the installation steps on your own. You just open the Play Store or the App Store and search for your application. And once you found the application, the Play Store or the the Play Store or the App Store are responsible for downloading the application, making sure that it's compatible and running on your device. You don't do anything. You don't configure anything on your device, right? The same exactly happen with Docker. Docker is, think of it as your Play Store or App Store for developers. I can download database, I can download Kafka, I can download Kafka Connect, any kind of tool that has Docker image, I can download it on my Docker containerization environment without caring how to run this on my own. The difference between container and image. I'm just thinking of analogy to be easy, but since I assume that we're software engineers, it's kind of the same differentiation between class and object. The class is the blueprint or the what they call it. It's the blueprint. The main thing of what your class is doing. Something like you're writing code in C++ or Java or Python, and you are creating a class called person. Okay, the class here is the image. Okay, the image here means that I have a class. This class contains of steps or attributes 1, 2, 3, 4. Name, age, uh, email, mobile, so on and so forth. Okay, but the instance of this class is a user called Karim. So I instantiated an instance from person. So container is the actual running instance from your image. I have an image, let's say here, called Connect, an image called Confluent Inc. CP Kafka Connect. This is the image. But I have a container running here called Connect. This is the actual instance of my image. Okay? This is the running instance. I hope I answered your question, Abdul. Okay. Let's go through the perfect. We have here a Docker Compose image. To have our system running, we have to have, as we mentioned, source, Kafka, and destination. Okay. The source in our case, actually, let me share my screen here as well. I can share from here. Okay. Anyway, so the source here is the MySQL database. So I need MySQL database, and we'll go through it here in the image file or the compose file. I need MySQL database. I need Kafka. I need Kafka Connect that will be streaming the data from my database to Kafka. And I need, that's it. That's the basic architecture. So let's go through the images I have here. I have an instance for the broker. I have an instance for the Kafka Connect. Schema registry is as you can remember, or if you remember, in the Kafka Connect image, we have the database, Kafka Connect, and converters. The converters are using something called schema to register the schema of the messages being processed. Okay, so this kind of schema need a store to store this schema, which is the schema registry. It's a place whereby a specific message has a schema, and we can track the versions of this schema through the schema registry. So we need the schema registry. KSQL DB server. As I mentioned, Kafka providing a solution called KSQL, Kafka SQL. It's a very fancy way to query topics and do stream processing on Kafka using something like SQL, not an ANSI SQL or the SQL from the database, but it's SQL-like. I'm using a tool called Provectus. Provectus here, it's a Kafka UI tool. It's used to visualize Kafka topics, Kafka brokers, and reading messages from Kafka. MySQL database, Prometheus and Grafana, let's keep them at the end. If we have time, we'll go through them. So let's start our demo. In order to start your Docker compose infrastructure, you can just run compose up. Okay. Here I have this Docker compose file. When I say Docker compose up, it just go and read docker compose.yaml. -d, it's called for detach. Detach here mean don't log all the events happening, just start and kill the this line. So we're gonna starting now the infrastructure. The very nice or the beauty of Docker infrastructure is that you can have very, very, very complex infrastructure and architecture, and you can just run it in a single command line. It's if you're a developer or a software engineer, you're gonna know how this is really hard. So we can check our infrastructure by doing docker ps. Let's close this. So we have everything up and running, up and running, up and running. Let's skip Prometheus. We're not, it's not intended for this session actually, but if we get time, we can debug it. But eventually I have the Kafka Connect instance running, the schema registry instance running, Kafka UI instance, MySQL broker checked. Okay. Let's see, I want to see the logs of my system, how it's behaving. We can just run docker logs -f. -f, it's a flag to follow like just tail the logs, get all the logs happening as we speak or as we go from the Kafka Connect. Here, I'm sending the name of the container. So the container name here is connect KSQLDB, Kafka UI, MySQL, and broker. So I'll go through the Kafka Connect. Here is the logs of Kafka Connect. So whenever a problem is happening, I'm getting an issue with my Kafka broker, I can tail the logs and see what's happening. Okay. Let's see the, okay. I now have lots of components up and running. How can I check them and make sure that everything is working fine? I need to check each and every component in a standalone mode. So brokers are up and running. So they looks good. Let's check Kafka UI. Kafka UI will be presenting the current brokers running, the topics inside each broker. So let's go here and go to the Kafka UI. So I have here a single broker, which is healthy. Okay. The broker code is, the instance name is broker. The port that's running for this broker is 9092. The online partitions are 38 and leaders are 38 as well. So let's get into this broker. Actually, the topics. Topics, you can consider it as the, for simplicity, it's a very simple approach as the tables inside this broker. Okay. We called it Kafka topics. Topics is like as if the road between Medan Juhayna, the Juhayna Square, for example, and Medan Lebanon or Lebanon Square. Assume this is the محور road. The محور road is, we can name it the topic, okay? And the number of the lanes of المحور are the partitions. So they are just doing widening the road or widening المحور a few months back. So they increased the partitions of this topic so that the flow of the data or flow of cars actually from let's say Sahrawi to Medan Lebanon will increase. This is the way how you can think of topic and partitions. Topic is the road, partitions are the lanes of this road. Okay. So Kafka contains of topics and each topic contained multiple partition or a single partition. single lane road, okay? And for simplicity, we're using the partitions for most of the topics, one partitions. But these are Kafka-related topics. I didn't create topics yet. So these are topics created by Kafka installation, have the default partitions 5, and the offsets table contains 25 partitions. Okay. Right now we have checked Kafka UI. I need to check Kafka Connect. How can I check my Kafka Connect? Kafka Connect here is running on port 8083. So from this line, I know multiple information that the container ID is whatever, the image running version, which version, the command that used to run this image, when created, up for what amount of time, or from when, and the ports. Ports here means that how I can access this image. So I can access this image from port 8083, okay? And it has also another exposed port, which is 8102. Let's skip this port right now, but let's focus now on 8083. This is the main port used to expose APIs for Kafka Connect. And the image name or the container name, Abdullah, where you're asking. So this is the image, the actual blueprint of the application or the Kafka Connect. And this is the actual instance I instantiated from this image. So I can have single image with multiple containers. So this is my container right now, the actual container, running container. Let's do something like curl localhost connectors. So it returned an empty array, okay? Empty array here, there is no connector so far. Let's open it also from the browser. Let's take this. And actually, it's already here. So I have an API or a URL replying to my request on the browser, which is returning an empty array. Perfect. Let's check the schema registry. How we can check the schema registry? We can also check the port that's been opened for this schema registry, which is 8081. And I can go hit the URL. No schema so far, but it replied, which means it's working. And finally, no, let's come to this later. So we checked Kafka UI, checked, Kafka Connect, checked, schema registry, checked. So we have a healthy infrastructure. The last thing that we didn't check yet is our database. Let's connect to our database. Let's refresh here. Okay, we've just created the database from scratch right now. So there is no schemas in the database. We need to create our schema again. And this is a test script I've used to for the demo purpose. Okay, let's go here. Yeah, the ecom schema created. Let's check the users table. We have 3 users. It's a very, very basic schema just for demo purposes. So yeah, we have 3 users, user 1, 2, 3, with an email and password. Right now, we need to test the source connector. Getting back to the diagram, we have the database, it's running. We have the connectors are running. The worker, here the worker itself is running, but we don't have connectors yet. Connectors here is the actual process running to stream the data from the source to Kafka. So we need to create a connector. Let's go and create a connector that stream the data from MySQL table or MySQL database to Kafka. as mentioned before, we have multiple formats we can use to store the data and retrieve the data from source to Kafka and from Kafka to the destination. These different formats are basically strings, plain strings, Avro is a format, protobuf another format, and JSON. I assume that you're all mainly familiar with JSON, which is this structure. So here, basically, I'm creating a connector configuration. Connector configuration here means that I'm creating a connector called MySQL connector JSON. The connector class is where the actual logic will be running from MySQL connector class. The database name is MySQL, database port, the root user for the database user, the database password. Server ID is a random ID used to just identify this server. The databases that I'm interested to listen to or stream data from, which is ecom. The topic prefix is the topic gonna be created for all the tables from this database. The schema history topic. This topic is used to store the updates happening on the schema itself. While doing any DDL, altering the tables, dropping the tables, adding new tables, changing types, all these DDL manipulations happening and linked to the schema history. The value converter, I'm using JSON for key and value, and include schema changes. I'm saying yes, please include all the schema changes to be tracked. Let's see how this is gonna work in action. In order to submit this connector as a job to my Kafka Connect, we used the APIs as well. Curl is a tool used to submit requests to and from servers or from client to server. So I'm just sending this curl request. I'm posting to the localhost connectors this file, but actually not this file. I want to MySQL connector JSON. Yes. Let's double check the name. MySQL JSON. Yes. So let's do this. So I got 201, which is created. Let's go here and check the connectors. I have my connector created successfully. Let's go for MySQL connector JSON. Here is the configuration. You can see your configuration here and the tasks as mentioned. So now you can visualize what we've been discussing. The worker is the Kafka Connect container. The connector itself is this one that we've just submitted to Kafka Connect. And the tasks inside this connector is MySQL JSON task 0. So worker, connector, task. Let's see the status of this connector. So thankfully it's running state. This means that the Kafka connector started up, listen to the database, and start to retrieve the data from the database. So how are we gonna assert this? How are we gonna check if the connector is working fine or not? First of all, we need to make sure that it's in running state. And yes, it's in running state. Let's go to the, Let's go to the Kafka UI portal. So as you can see that I didn't create these topics. I didn't create DSC-demo, items, orders, products, users. Can you imagine what are these? Okay, so these are the tables created in the database. So let's double check. We have table called users, products, orders, and order items. Let's go back to the database. We have users, products, orders, and order items. Checked. So let's see the users table. Let's get the messages sent from Kafka connector, get from the database to this Kafka topic. Okay, we have 3 messages here. Let's see the structure of these messages. Sorry, guys. Let's get this structure. We won't take too much in explaining it, but let's, for sake of illustrations. So this is the payload come from Kafka connector that read the message of the user's table and push it down the stream to Kafka. The schema here is a kind of a structure defining all the fields and all the data types in this payload. So it's a fields saying that, let's hear, yeah, struct, the user ID, the username, the email, the password, the timestamp, it's a time zone, or the created at its time zone. So this is one attribute. The other one, which is the before field. We'll see what's before and after. Same applies for the after field. We have another option here called source, operation, timestamp, microseconds or milliseconds, and timestamp nanoseconds. So basically, this is the actual logic or the actual payload. Let's skip all the schema. Let's delete it. We don't care about it that much. We care, but that much. Here is the payload of the message. There is the before and there is the after. What's before and what's after? Before is, it's, as we mentioned, it's a CDC, capture data change. What Kafka Connect is doing is listening to the bin logs in the MySQL. Bin log is something like a log file that capturing all the database actions happening. Sorry. All the database actions happening on the database, it's being logged in a bin log file in a raw format. Something like insert into MySQL, insert into users table values 1, 2, 3, 4. So this action, before being executed, it's logged in something called bin log. It logs all the actions. Okay. What the Kafka Connect is doing is capturing the values before a change and after a change, so that you can see the values for before equal null means that there is no before value, which means it's a new entry. It's a totally new entry. Okay. But we have after, which is the last version or the latest version. Okay. And we can confirm this from the operation. Operation here means operation equal R. What does R mean? I thought it would be C, like create, but it's R. Why R? R here happens for the initial snapshot. When we start the Kafka connector start doing something called snapshotting the database. It has to snapshot all what's happening in the bin log and get it to snapshot the data. Make something like an initial migration. Okay, I'll get back to this. I mentioned this in the early beginning of the session, but yeah, I'll get back to this, but right after the finalizing this part. So the operation here means read. Read. Yes, read here means that it's come from the initial snapshot action. Okay, so we have before, after. The source here means that it's coming from which connector, the timestamp this data has been taken. The snapshot here, it's last snapshot. Database name, timestamp, microsecond, and nanoseconds. The table this data is coming from, global transaction ID, the bin log file, so on and so forth. Some metadata about this table. But one of the biggest challenges and biggest problems using this kind of structure is this part, the schema part. From this view, can you see how much the schema part from the entire message? It's almost 6 times the actual message, which is very, very inefficient to use in production, especially at high scale or high traffic systems. So it's totally useless. I'm with every single message, I'm sending the same entire schema, which is almost 6 or 7 times the actual payload. Why should I do this? So that's why here it comes the concept of the AVRO or protobuf. All these are binary formats that are very, very minimal in size, very small footprint. And in order to, but again, how they solve the schema problem? How do the client or sorry, or the consumer know the schema or the structure of this message? The come to rescue is schema registry. Schema registry is the one who's responsible for the identifying the schema and tracking the schema updates happening on every and single message in JSON, Avro, protobuf. Okay, so we're using here. I just make this example with JSON in order to see the payload, the structure of the payload, how it looks like, in the messaging, so and so forth. Okay, so let's delete it and start with an Avro structure. First of all, we need to delete our connector. Okay. In order to delete our connector, we need to get the name of the connector. So here is the name of the connector. I need to delete it. It's now deleted. Let's double check. Not found. So let's get all the connectors. No connectors whatsoever. So we don't have connectors so far. Let's create our MySQL Avro connector. Actually, I think, okay. Okay, let's until the connector gonna be created, let's go through the connector configuration. So same as the connector class username configuration, topic prefix. The only difference is that topic prefix here, I just it's without the 11, so that the new connector work on a specifically new topics. The key converter, the schema converter. I'm using Avro here. So I'm setting the converter for the key and value for every message as Avro and providing the schema registry, whereby the Kafka Connect will be asking the schema registry about all the messages using the Avro converter. If the schema message or if the schema is not registered here, this connector will not be able to work. Okay. Since I'm working in an Avro fashion, I must have a schema registry link. And not only schema registry link, but a working schema registry link that when I ask for a specific message, it reply and saying, hey, I know the schema of your message, and here you go. Okay. Schema history, internal topic, we got the schema history. We didn't go through the schema history. Actually, we'll go through it right now. Transformers, let's keep it at the end, just for time. Let's run again. We have MySQL connector. I'm not forgetting your question, Ahmed, but just for sake of time. Here we have the connector. Let's check the status. It's running. It's working fine and running. Let's go for the Kafka Connect UI. Okay, so let's skip all these tables, all these topics. Just a second, guys. I'm sorry. Okay, sorry, guys. So here the topics for the demo 11, which is the old connector, and here for the topics without number 11. Okay, a good question. Okay, okay, cool. So why it's recreated? Nice. We have the connector when it comes to the registration with the database. It register itself with a name. Okay. If we re-register the connector again with the same name, it will not recreate the topics. But here we have MySQL connector and MySQL connector JSON. So this with a name and this one with a different name. So they looks totally different connectors, and each one register itself with a different name and a different consumer, hence a different topics. The other thing is the topic prefix. Here the topic prefix is DSC-demo, and here the topic prefix is DSC-demo 11. So they act as totally separate connectors. Okay, that's why it's recreated. Okay, let's check the topic. Here as you remember that we have the structure as JSON, that it's readable and we can go through it. Let's go through the same top table, but from the new connector. Messages. Oh, I think you cannot read this message. So can you see the difference in the footprint of the message? This is only the message. It's 61 bytes. Let's go see. This one is 61 bytes. Let's make it light theme. This is 61 bytes. Let's check the other topic. Users, messages. 3 kilobytes. Can you see the difference? 3,000 kilobyte versus 61 kilobyte. 61 bytes. Sorry. So it's a huge compression ratio. Okay, so we have the connector here is running. We have the schemas. We got now a schema. Why? Because we registered a Kafka Connect schema with an Avro structure, and this Avro structure linked to the schema registry. So we now have a schema. Schema for what? Schema for every single table. So let's check it. The table is composed of two values, the key and the value. The key of the table and the value is the actual record. So each table gonna have two schema entries, one for the key and one for the value. Let's compress all. So how many tables do we have? 1, 2, 3, 4. 1, 2, 3, 4. What is this extra 2? It's for the schema itself, the database itself. So here, user's value and user's key. This is the schema of the value, and this is the schema of the key. Let's check the one above. Products key and products value. Yes, it's very, very efficient when it comes to the data communication, serialization and communication. JSON is inefficient, especially especially if the JSON content itself is high and including the schema along with the message. So JSON is not the efficient way to communicate messages, especially when it comes to this part. But in API communication and machine-to-machine communication, it's usually used the JSON, but it's for a minimal API, minimal payload size. But when it comes to data transfers, no, we try to go away from JSON or plain JSON. So same goes or same applies for the orders, order key, and so on and so forth. So just we're starting to chasing the time. Yes, let's for example get the ID 10. So this is the schema for ID 10. And let's see if we have multiple versions for this scheme. No, we have a single version for this scheme. Okay. Now we connected, we created the connector. We streamed the data from MySQL to Kafka. And now getting back to okay, this will be applied as well, Abdullah. Just in order to it's one of the things that we're gonna test and how see how Kafka Connect gonna behave. But getting back to the initial problem, avoiding getting away from the Kafka ecosystem and technical stuff, we're trying to solve a problem for the data analytics team. I streamed the data away from the database. Okay, I did the first part of the isolation. I need to streamline the data again from my Kafka to BigQuery, for example, to so that the analytics engineer or the data analytics team can work on doing the modeling and analytics stuff. So as we mentioned, we have a source connector and sync connector. The source connector is the one that's running now. The sync connector, the one that we'll create right now, which is stream the data from Kafka to BigQuery. So we have the data here is ready and streamlined. Let's try something before we create the new user for user for. Let's do something like this and go here, refresh messages. Here we can see that there were 3 records. Now they became 4. Okay. Let's try to make a bulk update, something like this. Okay. This will result in 3 new records. Let's go here. It resulted in 3 new records. Okay. Unfortunately, we can't read them in a plain text. Let's try to use KSQL. But we'll try to move fast to go to the next part, which is the KSQL. As mentioned, it's an SQL on top of Kafka. Let's try to, I can access it instead of Kafka UI, I can do all the manipulations here. So I'm trying to show topics. Okay, I'll print users topic. Why it's working here and not working on the Kafka UI? Kafka UI don't understand the schema registry. KSQL understand the schema registry. So when I ask to print all the messages from table users or topic users, it know that its format is Avro and know that there is a connection between KSQL and schema registry. So it asks for the schema and try to deserialize the message using the scheme from beginning. Okay, so I have now, there is a transformer here. Let me update something else. Let me update the user ID to be 3, 4. Okay, so as you can see that since I'm streaming the data in a real time, it comes in real time without any polling or something like that. It streamed the new updates, the 3 updates, whereby the user changed from 4 to 4.5, from 2 to 3, and from 3 to 3.4. So this is the updates. A question that I was expecting is why the password here is hashed. It has nothing to do with the password. It doesn't know that it's a password field. This comes from something called the transformers. Transformers are an APIs, can be used on top of Kafka Connect to manipulate the data. Assuming that I have, for whatever reason, I have the passwords in the database in a plain text. I don't want to take these passwords from the database to external data warehouses or other users other than the tech team or the database team can see it. So I can apply a transformation on these messages before being persisted to Kafka and ingested downstream the system and mark it as asterisk or whatever. So here we can find this single message transformer. I have a transformer called mask field. This mask field, the check field called password, and replace it with asterisk. So I'm good to go with passwords being transferred from the system to other system without being worried about the data breaching. So yes. Okay. Good question. One of the limitations of Kafka is that in order to apply the database updates in real life scenarios, databases are not static. I always adding new columns, removing new columns, changing the data types. Data updates, to answer the Abdullah Muhi question that how schema change will be reflected downstream. In order to get this work, I need to do to apply a transformer called unwrap. Unwrap, remove the before section. So it keep it just as the new message only, as if it's keeping the after part only. Okay, Yusuf? So it's not applying the entire scheme. In order to be able to apply the updates from MySQL to BigQuery, I need to apply this transformer first, the unwrap. Unwrap, again, it's unwrapping or unpackaging the new message from the before and after and source and just get the new value. So yes, exactly. Both are exactly the same. Avro SMT, the one with the Avro and one with JSON. The only difference is that I'm not applying any transformer here. Okay, this only just applying the transform. Okay, let's get into the BigQuery part. Let me check that I don't have anything in BigQuery side. BigQuery here in a nutshell, you need to have a BigQuery is a data warehousing technology and stream processing actually tool by not stream processing, but AI and machine learning data engine by Google Cloud. And it was mainly data warehouse to process a large amount of data. So you need to have account, you need to have to create a BigQuery project and data set. Let's go quickly here. Kafka Connect, a BigQuery connector. The connector in the Kafka Connect ecosystem is depending on something called plugins. The plugins are the tools used to stream the data from Kafka to destination, which is the sync plugins, or from source to Kafka, which are the source plugins. So I'm using here Kafka, a BigQuery sync connector that takes the data from Kafka to BigQuery, and I'm using here MySQL connector, which is a a source connector that take data from MySQL to Kafka. So we might get to the configuration at the end, but just for sake of time, this is the normally configuration. Eventually, I'll create a GitHub repo with the entire test, the code base, and maybe we'll share it with you if you're interested. You can connect me on LinkedIn. So, schema registry, the project, the default data set, the value converter and the key converter, it has to be Avro so that it acts like SQL. When it asks for the data, it can check the schema registry and get the schema of the messages and deserialize it so it can process. This is a BigQuery configuration. When it comes to the write and batching, uh, since BigQuery is a cloud-based service, it has to be secured somehow. So we use something called service account. So I created a service account file and provided here so that the Kafka connector, the BigQuery connector, can connect to my BigQuery project. And this is a transformer I applied just to add a timestamp to the message before it's being processed. Let's create the BigQuery connector. So it's created. Let's go and see if it's working fine. Okay, it's created as you see. A BigQuery connector status. It's running. Let's hit multiple runs. It's running. Let's come here. I think I forgot something. No, okay, perfect. So let's get to our users topic and see consumers. So right now we have a consumer, which is the BigQuery consumer that will consume messages coming to the user's topic. And whenever a message comes to this topic, the consumer take it, which is our BigQuery consumer, take this message and send it to BigQuery. So, oh, okay. Let's see the status of the consumer. It's working fine, stable, no lag. Lag is the number of messages to be processed by this consumer. So zero means that it has no messages. So most probably it processed all the messages as we speak. The coffee got so cold. Anyway. Okay, now we have our end-to-end pipeline working from the database to BigQuery. Let's get into, I think, Abdullah question. Someone asked about updating the database, Abdullah. Uh, so here we go. The users messages from the Kafka topic, the Kafka users messages. So we have here 10 messages. Here we can see we have 10 messages. Yes, okay. So we have all the messages streamed. We have the field that added by the transformer to add the timestamp when it comes to processing. Let's update and let's do two updates. Update the table by adding a new record, for example, and adding a new column. Oops. Oops. Let's go here. As you can see, lag here is 1. Lag here is 1 means that a new message come to this topic and the consumer still is not catching up this message. It's now 0. Okay, let's go to BigQuery and do refresh. It's now existing. Let's do the final thing, which is updating the table. Update the table. Let's add a new column called status. One very important thing when it comes to update schema, and this schema is engaged in a CDC pattern. Try as much as you can, not changing an existing column. Changing existing column most probably will not work in most of the tools in the market. In order to make updates to the schema, it's always better to add a new column. It's really important when it comes to building CDC pipelines. Why didn't do an update statement? Update statement for what? Let me just create this first. Now we have a new status column. This will not make any difference in the database or the schema changes, as I added a column, but I didn't manipulate the data. I didn't do a DML action. Now let's do a DML action. I just adding status equal 1, for example, and pushing this update. First of all, let's go to see if this reflected here or not. Messages, we had already 2 new messages. They were 10. By now, they are 12 messages. Okay. Consumers. Updates take a little bit more time. So we will wait a couple of minutes until the updates are reflected. So what else we gonna see? We can see in the couple of minutes before this get updated. Let's refresh here. Let's go here and go to Kafka SQL. It's not reflected yet. It takes some time, unfortunately. But meanwhile, let's get the logs for Connect. Let's see what's happening. Is there any exception happening? Is there any problems happening when it comes to the new change? It seems nothing. All are normal logs. So let's wait a couple of minutes. Since we did a DDL action, and we mentioned that this topic is the one responsible for all the schema updates, to track all the schema updates. Let's try to print this topic from beginning. DCS. Okay. Let's see, alter. Here is the last action come to this topic, which is alter table users, add status and not. So in order to track what all happening in the system or in the database, we can just track the schema updates. Even if we don't have track record in the database itself, or the log has been flushed away or whatever, we can use this as a log history or audit for what's happening on the database. And lots of tools are using this kind of technique, not only for CDC, but replicating data between 2 databases, even the same database types. database in a region and another database in a region, they place in between them CDC, Kafka Connect CDC, that stream all the updates happening from this database and applying these updates on the destination database. Let's, I hope it works. Still didn't catch up for the two updates. I wish it get done before we why? Let me try something. I know we have 3 minutes, but the fun stuff with the demos. Thank you for the 15 guys or 13 guys are still stand still for this moment. I'm just risking to delete it. Okay, let's delete it and recreate it again with some tweaks. Let's do update. Now I'll recreate the name, maybe something like this. To create a new consumer, this new consumer will start processing from the beginning. Just immunization. True. I'm not sure we actually did this yesterday. Anyway. So, guys, if you have any questions or anything like this for the remaining minute and so, let me share with you my LinkedIn profile if you have any questions or want to discuss anything after. Here you go. Let's see the consumers. Yes, we have now 2 consumers. Users, consumers. Yes, Yusuf, Allah, it do updates since it's the hell of demo time. Yes, it do updates and but only adding new columns. Only add columns, not now it's synced it. However, you can see here. No, it's fine. As you can see here, it's already there, but for sake of since we recreated, I know we're over time, but let's do another quick update. Let's add a new column. Status 2. Execute. It has to be allowing null. It has to be no defaults and adding a new column. These are the 3 important conditions in order for the updates to be reflected. Let's add here and here. and push the updates. Now we might just take more couple of minutes, just a couple of minutes.
Yes, it's okay, no problem.
It's reflected. Can you see, guys? Status 2, I already, after getting the first batch, I added a new column, and the status 2 is created. But it's not reflected for the data yet. It added the column as an alter statement, but it didn't yet refresh the data. Let's see here if there is a consumer lag. There is lag here, yes, but it's gonna be consumed. Why? Because it already applied the alter statement. So I'm fine anyways. Since we have a number of them. Okay, maybe it will take more time, but anyways. So I hope as clear on doing the showing off the benefit of CDC, showing the importance of CDC, how it's gonna benefit from, how the company is gonna benefit from in case of analytics team, data science team. So by the way, here after this state, the data analytics team can feel free to go and work as much as they can on the data model, data analytics reporting in a separate from the streaming or from separate from the OLTP or the online transaction database. And they can build their own models. They can build their own analytics model, data warehousing. So it's a purely data warehouse structure. So they can benefit from as much as they can without impacting the users and the live systems. So I hope I was able to convey the problem and the solution. And by the way, there are lots of options and solutions other than Kafka Connect, but I usually stick to Kafka when it comes to these problems. So I hope you enjoyed it, guys, and really thanks a lot for staying that long, 2 hours for a session. So thanks a lot, and thanks a lot, Minna.
Thank you, Karim. It really was a great tutorial and great examples, by the way. And thank you again. Thank you, everyone, for attending the tutorial. We will have a break now and see you back here at 1:30. Thank you.
It got reflected, guys. It got reflected. Here you can see it for those who were waiting. So it got reflected. Thank you, guys. Thank you. Thank you. Bye bye.